The integration technique that we choose or use is based on the structure of the integrand. This video is primarily for students who have been taught all of the integration techniques in Calculus 1 or Calculus AB. It will not go into advanced integration techniques from Calculus 2 or Calculus BC. So let's take a look at our different integrands and how we decide what technique to use. I always just like to first look at it and ask myself, number one, do I know the antiderivative? Number two, if I don't, can I do a small alteration or manipulation of the integrand so that it becomes clear what the antiderivative is? For example, when our integrand is x squared plus 1 over x squared, we can break it apart into x squared over x squared, or 1 plus 1 over x squared. Each piece of the sum can be integrated easily without an advanced technique or without u substitution. Another example of that would be if the integrand was 1 plus tangent squared x dx. Just a simple replacement of that using a trig identity and replacing it with secant squared x, the antiderivative is readily apparent as tangent x plus c. So sometimes just a slight alteration of the integrand will do the trick. But what if it doesn't? So once we're fairly certain that we're going to be doing u substitution or a higher level technique, the big question becomes, well, what I always say with my students is, who you, or what is your u choice? I like to go to the inside function if there is one. By inside function, I can see I have that 3x to the 5th minus 5 inside of a root. So I let my u be 3x to the 5th minus 5, hoping to generate a multiple of the rest of the integrand. And I'd get 15x to the 4th dx for my du. So just with a slight numerical alteration, which I call a fraction correction, I can create the x to the 4th dx. Or maybe it looks like this. So it's not always an inside function. Sometimes it can be. Sometimes it can be something else. But just keep in mind, when you know it's u substitution, there's only a finite number of things to try for your u choice. Having done a million of these, it stands out to me that I should let u be tangent of 2x so that its derivative, or du, is secant squared 2x times 2 with our chain rule. And then again, I have that multiple of the rest of the integrand. This one could be done also by letting u be secant 2x, and I challenge you to think about why that would work. But let's suppose that doesn't work, that the inside function or one of the pieces of the integrand, I don't see its derivative as a multiple in the rest of the integrand. Well, don't go down a rabbit hole. There's always something else to try. So what if we have a quotient in the integrand? I always suggest try letting u be that denominator because we're hoping to generate that u prime over u so we can pass off to the natural log. For example, with this definite integral, if my u choice, and I have that quotient, is x squared plus 9, the derivative of it is 2x dx, which is living in the rest of the integrand as a multiple. So this would be set up to go all to the 1 over u du. Don't forget to change those limits because those limits are for x right now. So if we're going to pass the ball to u, we need to pass the limits to u as well. So don't forget that limit change with the definite integral. This one can be written as 1 over u du with some coefficients and can pass off to the natural log of the absolute value of u plus c. But let's suppose that didn't work. What's next? They're an exponential function in the integrand. If so, try letting u be that exponent. And think about why we would do that, because we know our antiderivative of e to the u du is e to the u plus c for our indefinite integral. And again, if we have those limits and change them, we can still use our e to the u. So here's a sample of that. I see that exponential function, that e to the cosine x. Try letting u be the exponent. Try letting u be cosine. What's its derivative? Negative sine x dx, a multiple of the rest of the integrand. So I could write this as negative e to the u du and integrate accordingly. But again, what if that doesn't work? We always have to try something else. So again, if that integrand is a quotient, we like to let that u be the denominator as a first choice. But if that's not working in one like this, notice u being x minus 2, my du is just 1. It certainly doesn't generate a multiple of the rest of the integrand. In that case, if you have these two polynomials, if the degree in the numerator is greater than that of the degree in the denominator, we try long division. And I know we might not like it, but we've been taught how to do it in Algebra 2 and understand that oftentimes at the end with our remainder, we end up getting a piece of the integrand that will pass to the natural log. But again, what if that doesn't work? What do? We look at the denominator and we see, is it looking a little bit inverse triggy? Is it sort of, I guess, Pythagorean, or do you see some perfect squares down in that denominator? Like this one, I'm seeing a 2 squared and I'm seeing an x squared, and my inverse trig antiderivatives are standing out to me. In particular for this one, the arc sine, u over a plus c. All right, so look in that denominator and see if it looks like it might go inverse triggy, if it's not going to go to letting u be the denominator and it's not setting itself up for long division. Remember, you've been taught everything that could possibly pop up. So if it doesn't work, don't go down the rabbit hole. Try something else. Maybe you have to try completing the square to make the integrand look inverse triggy, like on one like this. Certainly letting u be the denominator is not my choice, but I go there first. There is no inside function, but I know I've been taught how to do this, so I see that trinomial in the denominator, and I'm thinking maybe I could get it in the arctan format, where I have u prime over a squared plus u squared. Try it, and it'll work. But let's suppose it didn't. Do we have any other options? Any other tools in our tool belt? Don't go down the rabbit hole. Let's try one last thing. So lastly, maybe you need to write x in terms of your u choice. Some people call this a change of variable method. Haven't seen this on the AP exam or a practice exam yet, but that's not to say I never will. I've seen very little of the completing the square that passes off to the inverse trig. I've seen very little of the long division, but a little bit has popped up in practice tests these last couple years, so be prepared. Same as with this. So in this one, when I try letting u be that inside function, du is a 2. I can't get that x. So that sort of triggers the change of variable method. Go ahead and let u be 2x minus 1. But then solve it for x in terms of u, and get it all in terms of u du, and then integrate accordingly. So as you can see, there's a lot of techniques that we need to try, but the structure of that integrand should trigger your choice for integrating. Have a good day.